Today, I'm going to explain what is transistor and what are the types of transistor and how the NPN transistor is formed. So, transistor is a bipolar junction transistor. It is a three-layer, three-terminal emitter-base collector, three-terminal semiconductor device. Transistor uses both electrons and holes as a charge carriers. The main application of transistor is a switch, and it is also used as an amplifier. Okay, so this is the symbol of transistor, NPN transistor. In NPN transistor, the arrow mark is away from the base, and in PNP transistor, the arrow mark is towards the base. So types of transistor, PNP transistor and NPN transistor. The PNP, it is formed by two P regions sandwiching one N-type region, whereas NPN transistor, it consists of two N regions. It consists of two N regions sandwiching one P-type region. So NPN has two N regions and one P regions, whereas PNP has two P regions and one N region. So this is the construction of NPN transistor. NPN transistor, it is formed by sandwiching a P-type semiconductor between two N-type semiconductors. And majority charge carriers in N-type are electrons, and minority charge carriers are holes. And in the construction, you can see here N-type, P-type, and N-type. So the first N-type is the emitter region, middle one is base region, and the last one is collector region. Emitter is heavily doped. So it will have a high concentration of charge carriers. That is, electrons are the majority charge carriers in emitter region, and holes are the minority carriers. And the size of the emitter is small compared to collector, but it is larger than base region. The size of the emitter is small compared to collector region, but larger than the base region. And here it is heavily doped compared to collector region, heavily doped. Doping is the process of adding the impurity to a pure semiconductor. In order to form N-type semiconductor, we add arsenic, for example. So for each arsenic atom, we will get one electron. In this way, the majority carriers will be the electrons in N-type region. This is about emitter. Next, base region. The base is lightly doped. So it will allow most of the carriers injected from the emitters to pass through the collector. Whereas in the emitter, the injection of charge carriers into the base during the operation. All the electrons from the emitters, they are injected into the base during the operation. And whereas in base, it will allow most of the charge carriers injected from the emitter to pass to the collector. The size of the base is very thin, in order of micrometers. So that is about the base. Next is collector. The collector is moderately doped. Emitter is heavily doped. Collector is moderately doped. Moderately means lesser than emitter, but it is more than base. So this will allow it to collect the carriers effectively from the emitter through the base. The collector size is largest in the transistor. So this is about collector. The junction formed between emitter and base is called as base emitter junction. The junction formed between base and collector is collector base junction. Okay, next. So here I have made a table on the basis of a doping level. And emitter is heavily doped, base is lightly doped, collector is moderately doped. So heavily doped, it injects majority charge carrier into the base. Base, it allows the carriers to pass with minimal recombination because the size of the base is very small. And collector, it is moderately doped. It will collect the carriers and it will handle high voltages. The base emitter junction should be always forward biased during the operation, and the collector base junction should be reverse biased. So this is the base emitter junction should be forward biased and the collector base junction should be reverse biased during the operation. So emitter base junction forward bias and the collector base junction reverse bias. So how to make the base emitter junction forward bias? And if we connect p-type material to positive terminal of the battery and n-type material to negative terminal of the battery, we say that it is forward biased. So base should be connected to positive terminal of the battery and emitter should be connected to negative terminal of the battery. Then the base emitter junction is forward biased. And collector base junction should be reverse biased. Reverse bias means P should be connected to negative terminal of the battery and N should be connected to positive terminal of the battery. Here collector is connected to positive terminal and base is connected to negative terminal. So here the base should be positive towards the emitter side and base should be negative in the collector side. So if we connect like this, then we call the base emitter junction is forward biased. So when it is forward biased, the current starts flowing from the positive terminal of the battery through the base, through the emitter and back to the negative terminal of the battery. So that is the, there are two types of current, actual current and a conventional current. Actual current flows from base to emitter. Conventional current flows from positive terminal of the battery towards the negative terminal of the battery. Then here, okay. Biasing. The base emitter junction is forward. It requires voltage VBE. This voltage is called as VBE and this is VCB because this voltage is between base and emitter and this voltage is between collector and base. Forward bias, when we forward bias it, so it will repel the majority carriers in the emitter towards the base. And since the base is lightly doped, only a small fraction of electrons will recombine with the holes. So when we forward bias it, so the electrons in the n-type material, they are repelled and they are coming towards the base and they are attracted by the positive terminal of the battery. So because of this, the current starts flowing in the base emitter junction. Since this emitter base junction is forward biased, it reduces the depletion region at this junction, the first junction. So a high concentration of electrons in the emitter, and which is heavily doped in the emitter, it flows into the lightly doped, very thin base region. So these electrons will become the minority carriers in the p-type base region. So since the collector base junction is reverse biased, it creates a strong electric field. So the most of the electrons which enter into the base, they are swept into the collector by this electric field. So before they recombine with the holes in the base region. In this way, the electrons will move from emitter to base region. Next, the base is intentionally made very thin and it is lightly doped in order to reduce the recombination. Electrons will come and recombine with the holes present in the base. So because of lightly doped, the minimal recombination takes place in the base region. Only a small fraction, about 2 to 5% of electrons injected from the emitter, they will combine with the holes in the base. So this recombination produces a very small current, base current. That is, the current is referred as base current IB, and which is very small compared to the collector current, which is IC. Collector current is represented by IC. So the recombination which produces the base current, it is very, very small compared to collector current. So the some of the electrons will come from the emitter and they will combine with the holes in the base region, and the remaining electrons which are collected by the collector and forms the majority of the collector current. So because of most of the electrons will cross the junction and they come towards the collector. So in this current is called as a collector current. So that is represented by IC. Okay. And this is about current and voltage in an NPN transistor. Next is about the current. So the total current, emitter current, and leaving the emitter, it is sum of the base current and the collector current. So the formula is given as IE is equal to IB plus IC. The total current IE is equal to, which is coming from the emitter, IE is equal to IB plus IC. See the arrow mark here, IE enters into the emitter, and from the emitter, from the base it is going out, and from the collector it is going out. So IE is equal to sum of the base current and the collector current. So this is the main formula in the transistor. IE is equal to IB plus IC. One example let us take. If the base emitter voltage VB is 0.7 volts and small base current, that is in terms of microamps, how much? 10 microamps, and transistor gain 100. So let us take this example. The base emitter voltage is 0.7 volt. This one, the base emitter voltage is 0.7 volts. One example, and the base current is 10 microamps is applied, and the transistor gain is 100. So let us find the collector current from these three parameters. So before that, you must know what is current gain. Current gain is represented by beta. So the gain beta of a transistor, it is also called as current gain, and it measures how effectively transistor amplifies the current. It is defined as the ratio of collector current to the base current. IC is equal to, here, beta is equal to IC by IB. It is the ratio of collector current to the base current. In bipolar transistor, the beta value for NPN transistor, it ranges from 50 to 200. Okay, so here in this example, we have considered beta is equal to 100. So when a small current flows into the base of the transistor, it controls a large current flowing from the collector to emitter. So the current gain beta depends on indicates how many times the base current is amplified in the collector current. So that is represented by beta. How much current is amplified in the collector from the base current, that is represented by the current gain. So for small signal transistor, beta ranges from 20 to 1000, or for NPN transistor, 50 to 200. So it depends on the type of the transistor, and the exact value of beta depends on the type of the transistor and its model and the operating conditions. So from this, we will find the IC equal to beta into 100. Beta is given 100. IB is also given 10 microamps. The total current 100 into 10 is 1000. 1000 micro means 10 to the power of minus 6. So 1000 into 10 to the power of minus 6 is 1 milliamps. So now we will find the emitter current. IE is equal to IC plus IB. IC I got 1 milliamps and IB is 10 microamps. So it will become 1.01 milliamps. In this way, if any three parameters are given, you can find out the IC current and IE current. So this is one example. Okay. So in this way, you can write about the NPN transistor. Conventional current always flows from collector to emitter, whereas the actual current flow from emitter to collector.